I am David, super excited to be talking with y'all today. Yeah, it's a room full of builders in Web3 generally, potentially also on top of IPFS and Filecoin. And I want you to get excited about the products that my team's working on called NFT.storage and Web3.storage with the my mission today is to get you excited enough to go to the websites, check out the docs, and see if it fits well with whatever you're trying to build. So I'll start by talking about NFT storage and Web3 storage in the same breath, just describing them kind of abstractly as one, and then we'll dive into more of the specific differences between the two products in a little bit. Really, the core goal of what they're trying to do is provide users with an experience, a storage service experience that they're used to from traditional cloud storage. End users and developers alike have gotten used to super easy services and products, highly performant. There's tons of advantages with traditional centralized cloud storage providers in terms of these sorts of efficiencies. And we want to bring that to the table because those are objectively good things. And there's actually a lot of technology and lessons we can borrow from the last 15, 20 years of Web2. At the same time, we want to drive forward the primitives of content addressing and then having provable storage to the table and structure things in a way where you can benefit and utilize fast storage. If you don't want to get into the weeds, you can kind of throw it over the fence to us. But at the same time, there's no trust in the system because everything is verifiable. So trying to combine those two ideas with our products. Another way of looking at this could be looking at the flow of someone storing and retrieving data on our services. So at the surface, as a developer, or you might be interacting with Web3 storage and NFT.storage using very simple, familiar, performant interfaces. You have a JavaScript library, you download, you make an API token, 2 lines of code, you can store some data. That gets sent to edge workers. We're using Cloudflare right now. And you can retrieve that data quickly using, you can use IPFS, of course, but you can also grab it using HTTP. We have some aggressive CDN and caching out there to make that very fast and meet user expectations. But then underneath the hood, all the good stuff that Lucas teed up with IPFS and Filecoin are going on. And we take care of all that for you. So there's all sorts of things to worry about with making sure that data is propagated through the network and you're checking to make sure that it's actually there, managing Filecoin deals, all that stuff. And once it's on the network, it's on the network. So, and it has all the same properties as any other data on the network. It's provable. You can make sure that storage providers on the Filecoin network are actually storing it, doing what they say they are. You can get as deep as you want to, but you don't have to either. So it still remains trustless there, but at the same time, proof of space time sounds really cool. Like you might want to get a little bit deeper into things, and that's always an option for you. The reason why this is possible is because of content IDs. You can always, so when you store data with the services, you compute what the content ID is locally before logging it over the fence. So you know that the content you're storing corresponds with the content ID. And whenever that data is retrieved, you retrieve it using the content ID and you can verify that it actually corresponds to that data. So you can see how it has the contours of a traditional cloud storage service, but at the same time is totally different. Alongside Web3 content ID magic, there's tons of new superpowers waiting to be unlocked from Web3 innovations as well that we're really leaning hard into. So things like decentralized identity, really changing the paradigm of how we think about how data is controlled and accessed. And you can have a user with a storage account giving permission to applications to use it and flip certain models on top of their heads. There's all sorts of fun smart contract stuff coming. We are looking forward to the Filecoin virtual machine, for instance, so we can do things like enforce redundancy via smart contracts. You can check the Filecoin chain that data is being stored, and if any storage provider drops that, automatically through a smart contract, get another storage provider to store that data. If a deal is expiring, renew that deal, all that sort of stuff. Yeah, and I mean, this is a high-level overview. I'm getting a little bit into the weeds now, and I will more so later. But hopefully, that kind of gives an illustration of what we're about. We're super excited for both of our products, and I think IRL people get rightfully confused by the differences between the two products. It's going to be more obvious over time what the differences are, and here I'm going to highlight what the kind of the missions of each product are and what the use cases are for. So with NFT.storage, it's really oriented towards what it says it is, storing NFTs. And with NFTs, as you know, it's still the Wild West for NFTs, but it's a little bit defined on the problems we see with how NFTs handle off-chain storage. We're looking to solve those problems specific to NFTs. One is that you need to make sure NFTs, which are not completely on-chain, they have a pointer to off-chain data. They're pointing directly to the data that they want to be pointing to. So that NFT corresponds with a specific piece of data, and regardless of who on the internet has that data, how many copies are stored, whether those copies are moving around, you can always know that that NFT refers to that data and get that data back. And part of that is making sure that that data is persisted in the long term. So by using CIDs, not only can you point to that actual data, but it's really easy for you to replicate it as many times and as many places as you want to, as much as makes you feel comfortable if you have a stake in that NFT, but at the same time providing a multi-generational persistence layer for those NFTs ourselves, just being one of those places where you can feel safe that that NFT off-chain data is being stored. On the other side, Web3 storage is for literally everything else. It's a general storage product. You could build anything on top of it and anything that needs storage. And this will really lean into kind of the aforementioned Web3 innovations that are coming to the table to not only be an easy to use service that you don't really have to worry about, but one that integrates well with a lot of the cool stuff coming out of the Web3 space. And kind of as mentioned before, they share a lot of components and try to achieve a lot of the same stories. So that's kind of the middle part of this cool Venn diagram here. I'll talk more about this middle part now and then talk specifically more about NFT storage and Web3 storage after that. So in terms of what the two products share, we're providing production-ready decentralized storage. And this is kind of a topical thing in the Web3 space right now because us as an ecosystem, we're very much in the public eye today. Applications have real users with real expectations, giant investments in them. And on all fronts, these applications really need to work hard to deliver, and storage is a big piece of that. So what end users and developers who are used to using products built on top of traditional cloud services they demand fast and reliable storage, CDN speed retrieval, infrastructure that can scale to a ton of uploads, billions and trillions, and flexibility in storing any sort of data and being able to reference any sort of data, file sizes, variety of file types, private data, data that's changing, etc. And if any of you have worked with decentralized storage systems directly, you know that some of this stuff is actually kind of hard to do. So NFT storage and Web3 storage take part of the innovations we see from traditional cloud storage systems like edge workers, caching CDNs, elastic cloud infrastructure, and we want to utilize that alongside content addressing to provide that sort of service for you all, but at the same time be able to really utilize a lot of the cool stuff coming out of Web3. And the reason for being able to do this is because of the cryptography that IPFS and Filecoin are built around. So content addressing, as I mentioned, is a big part of this, as well as the Filecoin proofs. They're really the star of the show. It's really easy to compute CIDs locally, both when storing and retrieving. If we go down as a service, your data is totally safe. And Filecoin yields 6+ replicas stored with our services. And you can check the Filecoin blockchain at any point before or after a potential disaster situation with us to confirm that they're still there. And then we also store data with other pinning services like Pinata to maintain a ton of copies in the network. And then once data is on the network, you could really pull it down any way you'd like to, via HTTP, IPFS, whatever, and do the verification yourself and have the option to store more copies wherever you'd like. And part of this is also that a ton of innovations are coming, especially to Filecoin in the next year or so. I mentioned the Filecoin virtual machine, but there's stuff in the works to make Filecoin deals faster and create a retrievals market on top of Filecoin storage providers and things like that. And by using a storage service like ours, once data is on the network, you kind of get all those improvements for free. We'll kind of bring a lot of those improvements to the front for you, but like I mentioned, you can get as deep as you want to and take advantage of those yourself as well. So you're kind of taking advantage of this abstraction layer and hitching your wagon to it and taking advantage of a lot of the cool stuff coming. In terms of what this backend shared component between NFT storage and Web3 storage looks like, here's a diagram that hopefully makes things a little bit more tangible. At the top, you have a user storing data. They compute their CID. Their data gets put into what's called a car file, which is just a stream encoding of a DAG. That gets uploaded to Cloudflare workers, gets stored on our IPFS cloud infrastructure. That gets put into Filecoin deals. And our IPFS infrastructure serves that data to anyone requesting data. You can request it via IPFS directly, use any number of a set of public gateways, and then we also run our own gateway ourselves using Cloudflare again for caching and CDNing. And then, yeah, we also pin the data to Pinata, and once the data is out there, you can do whatever you want with it. So hopefully that gives you a sense of generally what these products are trying to do. With NFT.storage specifically, we'll talk a little bit more about what the product is about. We launched it in May 2022, so I guess at this point, just under a year ago. And currently there are 37.5 million uploads on NFT.storage, 22,000 users, and around 140 petabytes in Filecoin. And I think the actual number of NFTs that corresponds to is actually significantly higher than the 37.5 million number because a given upload might reference a bunch of NFTs. 10K NFT drops are a huge thing in the space right now. So for instance, a single upload could correspond to 10,000 NFTs being minted. And we're used by folks like OpenSea in the Solana ecosystem, some of the bigger marketplaces like Magic Eden, and a lot of individual projects. One cool thing we're seeing is that it's not just APIs, STAs, and minting services that are using us. It's a lot of individual artists who are hand-rolling things themselves. This is part of the cool thing about Web3, breaking down the walls of what it means to be an application or an end user, because you can, data is fluid, data ownership is fluid, because you're referencing things with primitives like CIDs. So with NFT.storage, what are we trying to achieve? Well, we want IPFS CIDs to be the standard in NFTs because these are unique fingerprints for the data, and we need NFTs to reference the data that they're actually pointing to, because NFTs are immutable references, and that definitely makes the most sense in most use cases, maybe not 100% of use cases. At the same time, we want to be one of the storage options that NFT creators are using to trust that the off-chain data is going to be persisted and available for the long term. And our service is free to onboard data on today, and we're going to do this for as long as we can. And once data is onboarded, it's going to be stored perpetually. One question we get is how we can guarantee that this perpetual storage is going to be the case. Talk a little bit about that by discussing what our mission is at NFT.storage. Our vision here is really to persist NFTs kind of as a public good. So if you think about what the potential of NFTs are, if done correctly, NFTs create a immutable data graph of the web. You have immutable references on blockchains pointing to off-chain content that ideally is pointing to unique identifiers of that content. And within those that off-chain data, so let's say an NFT is referring to some metadata off-chain. Within that metadata, you have other unique pointers to other data like images and assets and things like that. And you can start to see this graph form. And it looks, surprisingly, maybe not so surprisingly, like the actual web does. And it's a big problem in the real web to archive data that folks are using, but maybe gets lost. So I'm just old enough to remember GeoCities, and a lot of people reminisce on GeoCities as like this big thing where a lot of folks were relying on websites on there, and then it went down, and they lost a ton of information that they were relying on. So there are bodies like the Internet Archive who are preserving that data for folks. We want to help drive that sort of preservation for this new primitive of immutable data. So for us specifically, our plan is to write smart contracts on the Filecoin virtual machine coming out later this year to enforce levels of replication and renewal for data being stored on Filecoin, and fund this via a DAO. So it's completely trustless and transparent in the long term. It's deterministic as well, where you're not relying on probabilistic guarantees that a certain number of copies of the data will be stored on the network forever. You can just follow this smart contract is funding this storage provider to store it for this amount of time, and that will be continued to be funded through a DAO. And we have interest from a ton of different parties to keep supporting this, as well as I think it's the responsibility for folks like marketplaces to do this as well, and it's in their best interest. But this will also become, this tragedy of the commons problem become less of a problem over time as we do other things like make it more usual for new buyers of NFTs to feel responsibility to store a local copy of that data on their computer to just ensure that it doesn't go away. I think there's huge potential for folks like wallets to do that for you automatically, archive a copy on a local IPFS node of off-chain NFT data, that sort of thing. And this is going to just be one part of the puzzle. Taking a step back, you also just don't have to trust us in what we're doing, because as long as the data is on IPFS, if you have a vested interest in an NFT, you have the ability to store that data in as many places as you feel comfortable. Just really wanted to also quickly call out a related effort our team's doing to NFT storage called NiftySave. So we're scraping chains for NFTs starting with Ethereum and persisting that data on NFT.storage. So even if folks store data using location-based addressing or like in the future, 6 months later, might not be planning to pay their storage bill anymore, that data will still be persisted in NFT.storage. And we'll have more on this in probably a month or so, but also we're going to publish a data structure mapping NFTs to the CIDs of the off-chain data, even if they didn't use IPFS in the first place. So really the mission here is to preserve things for the long term as cheap to free as possible for folks. Moving on to Web3.storage. So everything else other than NFTs, check out Web3.storage. It's there for literally any other storage use case. We launched this in August 2022. Currently there's just under 14 million uploads, 6,500 users, and 81 petabytes in Filecoin. And yeah, you can think of us really as like a cloud storage provider where you can build whatever, end user facing dApps, developer tools. You can even build other storage services on top of us. I think Dropbox is still on AWS, that same sort of idea. We really just want to be an enabler for the rest of the ecosystem to be able to use IPFS and Filecoin and get the data on there as easily as possible. And once it's not there, you can do whatever with it. 1 petabyte will always be free for users with Web3.storage. The economic model of Filecoin, making storage super cheap, enables us to offer a lot of storage for free. And beyond that, today, actually, the story is past 1 petabyte, you can also get more storage for free. It's kind of a clunky, you share more about your project and request an increase in storage limits from us. And we're moving to more of a transparent model in the future because you would think developers love free storage, but they want transparency, surprise, surprise. So that's coming soon. I'll talk a little bit about that in a sec, but we think it's going to look like some sort of Filecoin staking model to increase storage limits. And alluded to this, but the roadmap for Web3.storage is really focused around unleashing the potential of Web3 and how that integrates with storage. So decentralized identity is a big piece of this. We're looking at UCANs. Our friends at Fission are creating this as a decentralized identity primitive. You can think of it as a decentralized way to grant others permission to use your account for things. Wallet authorization. One cool thing about Web3 is everyone has an identity. So let's really lean into that. I think it's going to totally unlock new data access patterns. And if you're thinking about, oh, I'm looking to build a new Facebook or a new Twitter or a new whatever, this can totally be the differentiator, these sorts of new models. And that's what we want to try and enable. One weakness of, quote unquote, weakness of IPFS just as a protocol is that it doesn't handle mutable references to data super well because it's a feature, not a bug, I guess. Every piece of data has a unique fingerprint. There is something called IPNS, Interplanetary Naming System, for mutable references that works well for certain use cases, but for various distributed hash table reasons isn't super useful in production. But we're looking to break those walls down. We have an implementation of IPNS for Web3.storage that's still in experimental phase, but you can check it out and it's totally usable. And you unlock a whole bunch of new use cases if you can have mutable references to data. And as I mentioned before, we want to allow users to expand how much data they can store with us through staking Filecoin. I think it's cool to offer a crypto native payment model to do this. That same Filecoin and yields from it can be used to, in the future, pay storage providers to fluctuate against, or to hedge against fluctuating storage prices, that sort of thing. And another cool thing that it unlocks is if end users want to create a Web3 storage account and give other applications access to storing data on top of that, it could be a sweet user experience for them to just be able to go into their wallet, stake some Filecoin that way, and then hold the folks who are actually storing data, kind of aligning their incentives with how much data that they're actually storing on the network. So think as far as incentive alignment goes, this is a really cool one. We're super excited about it with the Filecoin virtual machine. Give you a quick teaser on how to use our products today. Looks very similar to every 1, 2, 3 you see with every developer tool out there. But 1, create an account and token and install the client library. 2, in a few lines of code, calculate your CID locally and generate what's called a car file, and you store that. And 3, you retrieve the data using the CID. The easiest way to use either of these services today is through the JavaScript client library. It just makes it super easy to do the things you need to do underneath the hood. There are alternative ways of doing things that our documentation should let you know. And yeah, if you are part of the BIDL week and are interested in this, check it out. And if you have any more questions, please join us on the interwebs with our Discord and Slack, on Twitter. Talk to me after this. Even if you're not building in the coming few weeks, feel free to poke me on the shoulder. I'm happy to answer any questions. So all in all, hope this gets you excited about how simple getting data onto IPFS and Filecoin and using CIDs can be. We want to just make it as easy as possible for web developers to be able to use these new superpowers. Thank you.